Hey, artists. I am so excited that we get to go back to school. I don't know about you all, but I really missed Tanana. I missed seeing you all there, and I missed making art together. I really enjoy our art classes and am thrilled to get back to doing it, even though it's just online. Right before spring break, we were working on a color unit. We were all working on creative color wheels and creating color with the primary colors red, blue, and yellow. I wanted to extend that just a little bit and think about how our eyes see color and light and how that science applies to making art and how to help you guys be amazing artists using color and light and what you know about science. So this first video is going to be more sciencey than any of the others. After today, I'm going to be mostly focusing on color and light and how you can use that as you make art, any kind of art. You can use it as you make jewelry, you can use it as you make paintings or drawings or cartoons or sculptures, whatever you see in your future. So, first thing I want to talk to you guys about is the electromagnetic spectrum. I know that when you think about light, you probably, just like me, think of what you see around you in the light. But the light that our eyes can actually see is just the beginning. It's just a tiny little sliver of all that's available out there. From radio waves to gamma rays, most of the light in the universe is in fact invisible to us. The electromagnetic spectrum is the term used by scientists to describe the entire range of light that exists. Light is made up of waves of alternating electric and magnetic fields, which spread out like waves across an ocean. Although the visible light from the sun looks white, it's actually made up of multiple wavelengths or colors of light. You can see these different colors when white light passes through a prism. The different wavelengths of light are bent at different angles as they pass through the prism, and then they spread out and form what we see as a rainbow. Now, we just talked about that huge spectrum. So now we're going to focus in on the visible spectrum. That's the only part of that huge electromagnetic spectrum that our human eyes can actually see. An easy way to remember the colors is Roy G. Biv, and I know you've seen that before. You've seen that frequently, in fact. So we can see red, orange, yellow, green, blue, and violet. The human eye is just amazing. It works together with the brain to translate light waves into colors. So there are light receptive cells in the back of the retina in the eye that transmit messages to our brains, and then we produce color. Your brain is amazing because color is not inherent in an object. Instead, the surface of an object reflects some colors and absorbs all the rest. And so we only see the color that's reflected off of an object. So red is not in an apple. Instead, the surface of the apple is reflecting the wavelengths we see as red and absorbing all of the rest. An object actually looks white when it reflects all of the wavelengths that are possible, and it looks black when it's absorbing all the wavelengths that are possible. Now, remember, we're looking at science. We're thinking about science here. The scientific additive primary colors are actually red, green, and blue. Those are the colors that our eyes see. That's the colors that the cells inside of our eyes are sensitive to. And by varying the amount of red, green, and blue light, all of the colors in the visible spectrum can be reproduced. Now, I am going to talk more arty next time, but I wanted to keep this really short. Here are some places that I went to look up some information to make sure that you guys would understand what I said. Wikipedia, of course, and then Pantone is the color people in the US and around the world, really. They tell you a lot about color and how color works. And Earth Sky is a science website that uses a word of the week to teach students about science. I hope to see you next time so we can talk about art. Bye.